everybody, it's Miss Austin. I'm going to be going over the Unit 4, Lesson 7 problems. So we have started learning right triangle trig, and we have now learned that these ratios have names, cosine, sine, and tangent. It says, Maya is visiting Paris to see the Eiffel Tower. She is 80 feet away when she spots it. To see the top, she has to look up at an angle of 85.7 degrees. How tall is the Eiffel Tower? Okay, well, Miss Austin's not going to try to draw the Eiffel Tower, right? Something like this, right? I don't know, with a bunch of metal. Okay, here it is. She's standing 80 feet away from it. Here she is. Hello. And she looks up at the top of it at an angle of 85.7 degrees. And it says, and this is a right triangle, right? This is why we get to use our ratios. How tall is the Eiffel Tower? So I'm trying to find that side. So here we go. Given this angle, that's opposite. And that gave me the adjacent. Which trig ratio is opposite over adjacent? Tangent. So the tangent of 85.7 is opposite, which is the I don't know, over the adjacent 80. Now I'm trying to figure out what x is. One way that always works is to create a proportion out of it, right? Put a 1 under this and cross multiply. 1 times x is x. This is just a ratio that's been stored on your calculator. I wouldn't type it in, until the very end. So now you just have to go to your calculator and type this in. You do want to make sure whatever calculator you're using is in degree mode. So you would type tangent of 85.7, close that, that's the degree, times 80. If you put the 80 in with the parenthesis, you're not going to get the right answer. So the Eiffel Tower is about 1,064 feet. Approximately 1,064 feet. Find the missing measurements of the right triangle. So now we've got to find everything that's missing. I think it's I don't know why, I just always find the angle first. I know these two have to add to 90 because 90 is already taken there. So that's going to be what, 63? You put 90 minus 27, okay, so angle B. Now, which side do you find first? Your choice. I'm just going to call, this is little b and this is little c. I'm going to find B first. Does it matter which angle I use? No, I'll use 27. So that's the adjacent, and I know the opposite. Opposite over adjacent is tangent again, right? So tangent of 27, why 27? Because that's what I chose, is the opposite 12 over the adjacent, I don't know. Put a 1 under this. 12 equals the tangent of 27 times I don't know. This problem requires an extra step because the value you're looking for needs to get isolated. So now divide by tangent of 27. Okay, that's going to go away. So my missing side is whatever I get when I type this in. 12 divided by the tangent of 27. That side is about 23.55. Actually, sides we normally go to maybe the tenths. 23.6. Now, how do you find the next side? We could do trig again. We could also do Pythagorean theorem. Since we're just learning trig, I'm going to use trig again, okay? So I'm going to use 27 one more time. That's the opposite. And now I'm looking for the hypotenuse. Opposite and hypotenuse is sine. The sine of 27 is opposite over hypotenuse. All right, create a proportion. 12 equals the sine of 27 times c. I need to get c alone. Whatever I do to one side, I do to the other. And now I'm going to type that in my calculator. 12 divided by the sine of 27, 26.4. And remember, like a quick little check, is the hypotenuse should always be the biggest. The smallest angle has the smallest side across from it. The middle angle has the next biggest side, and then the hypotenuse always has to have the biggest. All right, number 3. Gateway Arch in St. Louis, Missouri is 630 feet tall. So imagine there's an arch. And it's 630 feet tall. I'm going to be kind of, Priya can look up at it at a 50-degree angle. So you got to kind of imagine, I'm going to draw it from the side, okay, the triangle, because it's actually coming straight out, but I'm just going to draw it this way. Hopefully you can imagine it. Okay, she's over here at a 50-degree angle to the top of the arch. How far away from the base is she? So this time we've got opposite and adjacent. Tangent. Tangent of 50 is opposite over, I don't know, create a proportion, 630 equals x times the tangent of 50. Got to get x alone. Divide by the tangent of 50. Remember, all this is a ratio that's been recorded and stored in your calculator. So now we've got 630 divided by the tan of 50, about 528.6 feet. All right, moving on. Number 4. Based on the figure, which equation is true? All right, let's check. Sine of 32 is 8.5 over x. Well, sine is opposite, yes, over hypotenuse. Yeah. Sine of 32 is x over 8.5. That would be the hypotenuse over opposite. No, I don't know if more than one of these is right. Cosine, no, I guess there's just one right. We got it on the first try. Cosine would be adjacent. I would need this side. This is my adjacent side of 32. There's nothing about cosine. A. Kieran is flying a kite. He gets tired, so he stakes the kite into the ground. The kite is on a string that is 12 feet long and makes a 45-degree angle with the ground. How high is the kite? Okay, so now notice the answers are in radical form, but we can work around that. So they want to know this. That's opposite. That's hypotenuse. Which trig ratio uses opposite and hypotenuse? Sine. The sine of 45 is opposite over hypotenuse. So we've got x equals the sine of 45 times 12. Now, when you're typing this into your calculator, if you type that first, if you wrote it this way, you don't have to worry so much about closing that parenthesis. But on this, you've got to make sure you don't put the 12 in with the 45. Sine 45 times 12. 8.49. And then you're like, wait a sec, none of those answers say that. Well, we need to convert them. I know it's not 12. Okay. I know it's not 24. Which one of these is 8.49? Use your calculator. 12 divided by the square root of 2. There it is, 8.49. This one, just to show you, would be 12 times the square root of 2. That's 16 something. So it's this one. Number 6, match the ratio to the corresponding angle. So we know how to find missing sides using trig, but we still don't know how to find angles, which we will. So we're going to go back to this chart. So if an adjacent over a hypotenuse, that's cosine, has an answer of 0.139. So that's down here in between 0.139, it'd actually be past 80, right? Because that's 0.17, that'd be past that. Well, which angle would that have to be? That one right there. Opposite over adjacent of 0.249. Opposite over adjacent of 0.249. So somewhere between 10 and 20, let's go look. The only one between 10 and 20 is right there. Opposite over hypotenuse of 0.469. Opposite over hypotenuse of 0.469. So it'd be between 20 and 30. That's that one right there. Adjacent over hypotenuse of 0.682. adjacent over hypotenuse of 0.682. That's going to be between these two. So between 40 and 50. And then opposite over hypotenuse, let's just make sure this is right, of 0.848, up 0.848. Be between these two. Oh no, between these two. Because it comes before 0.86. So between 50 and 60. Yep. Use the chart. Eventually we're going to learn how to find the angles using our trig ratios too. Last one. In the right triangle shown, the measure of angle ABC is the same as the measure of EBD. So they marked those for me. What is the length of side BE? Well, these two, right? These triangles are similar. So this proportion should be the same as this proportion. We could set up a proportion, right? Here we go. So 5, this isn't the only way to do it. So I'm doing the leg over the hypotenuse of the big triangle is equal to the leg over the, I don't know, call it x, on a little triangle. 5 times x equals 39. Divide both sides by 5. 39 divided by 5. 7.8. Right. I hope this helped. I'll see you soon.